Hi, this is Patty Latch at the Switzer Library, and I wanted to just share a really fun experiment that I learned recently, and it has to do with Skittles and rainbows. How cool is that? Now, this is for some science for you to figure out yourself. I'm going to take the Skittles, and you'll see that they're arranged by different colors along the side of a plate that will not melt or in water or in the heat. And then I have some clear liquids, a soda. I have some milk just because I thought that might be interesting. I have cold water and I have hot water. And then I have the Skittles. Now I put the Skittles before I arranged them. I just poured them on that plate because I don't want to reach my hand in the bag and then put stuff back. So of course now I have put these on, I poured those onto the plate. Those were extra. I didn't need them here for my science experiment, so I will have to just check how they taste afterwards. So, science. I want you to figure out why this works. What works? Does it all work the same way? I think it has something to do with the sugar content and potentially heat. So that's why I have cold water and hot water to see if one works better than the other. Now, I'm not going to try the milk and all because I want you to just think of things to try at home. So that's why I just gave that example. You might want to try hot and cold. There's another experiment I found online where you can make a rainbow jar. So if you Google that, it will tell you the science behind making so that the colors stack up and you can figure out why that works. So you see this is going to be the cold water, and we're just going to very gently pour it in so that it doesn't move the Skittles all over the place. You know, those little guys, they like to roll around. So don't move the table and don't move anything, and we'll see what happens. And now this will be the hot water. I can see that these are starting to melt a little bit, so let's try the hot. The hot water is not all the way boiling. It's warm water. It's pretty warm, but it's not totally boiling. And I'm going, oh, this is so cool. Miss Susan, can you see what it's doing over here? Miss Susan is filming this for me. So you'll notice that the hot water is moving faster, isn't it? But they're both making these very cool rainbow stripes. Isn't that weird that they're not mixing? These have just like a little, I'm not sure why it's doing that. But see this one, which is the second one I did, is closing much faster. This one is still causing the colors though. So why do you guys think it's doing that? Why do you think the hot works better than the cold? Do you think that milk would work? Could be really pretty to have the rainbow in the milk. Do you think that it will stay this way? If you don't touch it, if you don't shake the table, if your little sister or your dog or your cat doesn't jump up on the table and joggle it, do you think that they will stay in their little lines, in their rainbows? You can make notes and see why you think. I wouldn't write on the table because that might joggle the table, but you can make a scientific thought in your brain. You can say, I think it's going to do this, and then you can see if you can prove that. And then you can see if, you know, what seems to work best. So I look forward to hearing about your science experiments when I can hear from you again. Thanks, I really appreciate seeing you online at least. Bye.